Today, we are looking at divisibility rules. Let's take a look at what it means when we say that something is divisible. But wait, first, a disclaimer. All numbers are divisible by all other numbers. They just don't always give you a whole number as an answer. They might give you remainders in the form of decimals or fractions. So when we say that numbers are divisible by each other, we're talking about whether or not we can divide them without there being a remainder. Okay, let's get into it. First of all, the word divisibility means having the ability to be divided or shared equally. For example, if we said that 6 is divisible by 2, it means that if we were to share these 6 little circles between, let's call these 2 people, we can see that 6 circles divided by the 2 people or the 2 groups will give us 3. We can see this because there are 3 circles per group. So let's look at some rules that we can learn to help quickly determine whether or not something is divisible by a given number. Firstly, we have the number 1. Well, we know that everything is divisible by 1. We can prove this by looking at these 4 circles and sharing them into one group. You can see that I could put all of those circles into that one group. This proves that everything is divisible by 1. Let's have a look at the number 2. In order for a number to be divisible by 2, the last digit must be an even number. Remember that even numbers are numbers that end on a 0, 2, 4, 6, or an 8. For example, if I had 922 and 829, I know that I need to look at their last digits. In the first number, the last digit is 2, so that is an even number. But the second number's last digit is 9, which is odd. So this means that the first number is divisible by 2, but the second number is not. You can determine whether a number is divisible by 2 just by looking at that last digit without needing to actually work it out. To find out if a number is divisible by 3, we need to find the sum of the number's digits. If your answer can be divided by 3, then the whole number can be divided by 3. Okay, let's look at a couple examples to better understand this. The first number we are going to look at is 1,327. If I had to add the individual digits, I would say 1 plus 3 plus 2 plus 7, finding their sum, right? And that gives you 13, so 13 is the sum. Since this answer of 13 cannot be divided by 3, that means the number itself can't be divided by 3 either. In our next example, we look at 4,215. When I add the digits together this time, I get an answer of 12. 12 is in the 3 times table, so that means that this number can be divided by 3. Numbers which are divisible by 4 will always have their last 2 digits divisible by 4 as well. The number 732 is divisible by 4 because the last 2 digits are 32, which is a multiple of 4. But the number 849 has 49 as the last 2 digits, which we know cannot be divided by 4. Therefore, only the first number is divisible by 4. Numbers divisible by 5 are easy to identify. They always end on either a 0 or a 5. 2,045 ends on a 5, so this is divisible by 5. 6,231 ends on a 1, so this cannot be divided by 5. Lastly, 960 ends on a 0, which means that yes, it can also be divided by 5. The number 6 is a little trickier to work out. First of all the multiples of 6 are even numbers, so that is one thing we need to look out for. The number 242 is even because it ends on a 2, so it is possible that this number can be divided by 6, but only possible because there's a second condition that the numbers need to meet. In addition to being even, which also means that they are divisible by 2, the numbers also need to be divisible by 3. Can you remember what that means? It means that the sum of the digits needs to be able to be divided by 3. So when I add 2 plus 4 plus 2, I get 8. Since 8 cannot be divided by 3, the number 242 is not divisible by 6. In our next example, we have 243. We can immediately see that this number isn't a multiple of 6 because it is an odd number and not an even number. Even though when I add the digits, I get an answer of 9, which is divisible by 3, since 243 doesn't meet both of those conditions, it's not divisible by 6. 816 is an even number, and when I add the digits together, I get 15, which is a multiple of 3. This means that because 816 meets both conditions, it is divisible by 6. One way to remember both of these conditions is to remember that 2 and 3 give an answer of 6 when they're multiplied. So, a number is divisible by 6 if it is also divisible by 2 and 3. Okay, the number 7 needs some brain power to figure out. Let's break it down. There are 2 steps to finding out if a number can be divided by 7. First, double the last digit. Then, look at the number formed by the rest of the digits and subtract the 2. Then, if your answer can be divided by 7, then the whole number is divisible by 7 too. Okay, this is confusing. So let's look at an example. Take the number 718. Step 1. Double the last digit. The last digit is 8. So double that is 16. Remember that number. Second step. Look at what's left over from the number. I still have the digits 7 and 1, so essentially 71. If I were to take this 71 and subtract it by 16, remember, double 8, I get an answer of 55. Since 55 is not in the 7 times table, 718 is not divisible by 7. Okay, let's try this again. 496 ends on a 6, so we need to double that, step 1. We get 12 when we do. Now, we look at the remaining digits, which read 49. 49 minus the 12 gives us 37. So because this isn't in the 7 times table, this number can't be divided by 7 either. Are you starting to get the hang of this? Let's look at one more. 182 ends on which digit? It ends on a 2. What is double 2? It's 4. What digits are we left over with? We are left with 1 and 8, which we can read as 18. What do we do next? We subtract the 18 and the 4. What does this give us? 14. Is 14 divisible by 7? Yes. Yes, it is. So does that mean that 182 is divisible by 7? Yes, it does. Okay, so this might be the nerd in me speaking, but I think finding numbers divisible by 8 fun. All you have to do to find out if a number is divisible by 8 is halve it 3 times. So, the number 2024 halved gives us 1012. We can halve this a second time, which gives us 56. And then this can get halved for a third time, which leaves us with 28. And since we were able to halve this number at least 3 times, we know that 2024 can be divided by 8. The number 1506 gives us 753 when halved. Since this number ends on a 3, it means that it is odd and cannot be halved any further without giving us a remainder. So, 1506 cannot be divided by 8. The number 1000, however, can. The first time it is halved, we get 500. The second time gives us 250, and we are able to halve it just one more time to get 125. 9 is easy to remember because it's like the rule for 3. And, funnily enough, 3 is a factor of 9. If the sum of the digits are divisible by 9, then the whole number can be divided by 9 too. When I add the digits of 156, I get 12. 12 is not in the 9 times table, so 156 cannot be divided by 9. 639 gives me an answer of 18 when I add all the digits together. Since 18 is a multiple of 9, the number 639 can also be divided by 9. Okay, I think we can all agree that 10 is probably the easiest number to remember out of them all. Only numbers ending on 0 can be divided by 10. 345 ends on a 5, so it is not divisible by 10. But 160 is divisible by 10 because it ends on a 0. Okay, back to putting on those thinking caps. Numbers divisible by 11 need some concentration. To find out if a number is divisible by 11, you need to subtract and add digits in an alternating pattern, always starting with subtract. So this means you minus the first two digits, then add the next digit, then subtract the next digit, then add, and so you carry on until you run out of digits. If your answer comes to 0, or if your answer is a multiple of 11, then your number can be divided by 11 as well. Okay, examples please. 1,397. Subtract the first two digits in order, even if it means you get a negative answer. 1 minus 3 gives us negative 2, and that's okay. Add negative 2 to the next digit, 9, and that gives us 7. Subtract the next digit, which is 7, from this 7 we worked out, and we get 0 as an answer. This means that 1,397 is divisible by 11. Fun, right? Or is that just me? Okay, let's check on another. 7,150. Right, first two digits, 7 and 1. So let's go. 7 minus 1 equals 6. Next we add. 6 plus 5 equals 11. Now we subtract again. 11 minus 0 is 11. We obviously know that 11 is divisible by 11, so this means that 7,150 can be divided by 11 too. Let's try one more. 9,842. First two digits are 9 and 8, and when we subtract that, we get an answer of 1. When we add this 1 to the next digit 4, we get 5. Now it's time to subtract again. 5 minus 2 equals 3. Since 3 is not a multiple of 11, the number 9,842 cannot be divided by 11 either. Okay, deep breaths. We are nearly at the end. We can say 3 times 4 to get 12, right? Well, remember this the next time you're trying to work out if a number can be divided by 12. Just like the number 6, which is half of 12, had to meet 2 conditions, so does the number 12. Numbers which are divisible by 12 need to be divisible by both 3 and 4 as well. Can you remember what that means? A number is divisible by 4 if the last 2 digits are divisible by 4 as well. And remember that we add digits to see if a number is divisible by 3. Let's jump in. 132 ends on 32, which is in the 4 times table. When I add the digits together, I get 6 as an answer, which is a multiple of 3. Since both conditions are met, 132 can be divided by 12. 489 ends on 89, which is not in the 4 times table, even though when we add the digits we get 21, which is a multiple of 3. Since the number doesn't meet both conditions, it cannot be divided by 12. Let's do one more example. 328. It ends on a 28, which is in the 4 times table. But when I add the digits, I get 13, which is not in the 3 times table. Again, since both conditions haven't been met, the number 328 is not divisible by 12. And there you have it. Divisibility rules for the first 12 times tables.